Next, we want to take a look at some of the common issues that occur in 3D printing. We'll start with FDM. It's important to remember, 3D printing is not always perfect. Bad prints will cost you lost machine time, material, and a great deal of frustration. Without proper planning, even hidden geometry can fail at a later point in time. We should always consider our CAD geometry when designing for 3D printing. As more and more companies do 3D printing, they struggle with the imperfect geometry. Whether it was scanned or from another CAD system or an STL file, when it came time to print parts, people were having difficulty getting valid geometry. The points of model failure are important to consider. The design considerations are anisotropic parameters, the material properties, use and abuse, the stress of the product, and the environment it will be used in. Remember, we're working with a mesh file that represents a smooth surface. When the resolution is too low, we get poor geometry. When the resolution is too high, it causes a huge file size and slows down the process. We're always looking for a balance between file size and resolution for the appropriate geometry. When we're looking at slicing non-manifold files, we can run into trouble. A manifold vertex has the outer edges closed to form a loop. A non-manifold vertex, the outer edges do not form a closed loop. Bad geometry will cause failed 3D printing. The slicing software doesn't always fix an open mesh. And some software will warn about the mesh, while others do not. And some programs are better than others for repairing our broken mesh files. When in doubt, repair the file. You need to understand your slicing parameters. When designing for 3D printing, think about the material first and select the appropriate filament type for the job. Consider its properties, its diameter, the temperature at which it softens, its melting temperature, and the elongation temperature, as well as its tensile strength. The application temperature is also important. The bed temperature will affect adhesion to the bed. The nozzle temperature affects the print quality in details. The chamber temperature is important to keep parts thermally stable when working with materials such as ABS. Notice how the part in the graphic has lifted off the print bed and is ruined. The printer and how well it's built will greatly affect how fast you can print, and the speed affects the quality. The more rigid the machine, the faster it can print. Always consider your various structure parameters for each print job. Keeping the extrusion speed slower will create a better print job, but take longer. The starting G-code is critical for a good print. The ending G-code can also affect your print quality. As a reminder, here is a summary of some common G-codes used in 3D printing. Supports are critical. Remember the 45-degree rule. It affects overhangs and bridges. The next consideration is how we lay down the first few layers. Do we use a raft, a skirt, or a brim? A raft is a horizontal latticework of filament that is located underneath your part. Your 3D printed part will be printed on top of this raft instead of directly on the build platform surface. A skirt is an outline that surrounds your part but does not touch the part. A brim is a special type of skirt that is actually attached to the edges of your model. Typically, the brim is printed with an increased number of outlines to create a large ring around your part, similar to the brim of a hat. All these parameters are just the tip of the iceberg.